Hello, dear students. I'm Kashif Ibrahim, and this is part two of the operating system series. In previous lesson of A2 level computer science operating system, we have discussed some basic concepts of operating system. Let's have a quick recap of what we have discussed in the previous class. We started our lesson with the definition of operating system. Then we have seen some examples. Then we have seen some functions of the operating system. And we have seen that providing interface, CPU management, multitasking, time sharing, memory management, peripheral management, file management, providing security, and providing utility software. These are the jobs of the operating system. Then we have seen some basic concepts. What is BIOS and what is bootstrap program and what is booting. We have seen that bootstrap program resides on BIOS, and this is responsible to load operating system from secondary storage to memory. Then we have seen some concepts of functions of operating system. We have seen interface. What is interface? Its type, and what is CPU resources. Then what is CPU resource management? Then we have seen the concept of DMA, and because of DMA, CPU gets some relief and it keeps on doing its own job. Otherwise, it will stuck with IO request. Then we have seen the concept of kernel. Kernel is the main and core part of the operating system, which is dealing with different IO requests and different other jobs. Then we have seen the concept of process. What is a process? A process is the program in execution. Then we have come to process scheduling, and we have seen that computer can execute a number of processes at a time, and if there is only one CPU installed in computer, then its time is divided with the concept of multitasking and time sharing. Multitasking means executing more than one task in memory, and time sharing means dividing CPU time so that those multiple tasks could be executed. The time which is given to a particular process, that is called time slice. So a process may require multiple time slices to be completed. Then we have seen the concept of burst time, process starvation, and scheduling algorithms. We will see these in detail also. Now in today's lesson, we will see different concepts of process times, and then after that we will see that what is process scheduling, and then process control block, and then we will see the diagram which is given in your book, process execution diagram or PCB diagram. Let's start. Before going in detail, we should understand different times which a process can have. You know that process is initiated whenever user runs any program. A process is initiated. Quite possible that the part of the program which is loaded in the memory, that will create a process. So that will be the arrival time of the process. So process can have an arrival time. Then what is waiting time? This is quite possible that as a process is generated, CPU is already busy executing some other process, so it will be put in a waiting queue, and that will be called waiting time. So waiting time can be evaluated by using a formula, that is turnaround time minus burst time. Burst time, I have already told you that burst time means the total time taken of CPU taken by any process. So quite possible that process is completing its task in 4 time slices. So for example, one time slice is of 2 microseconds, then burst time would be 8 microseconds. So total turnaround time means that how much time it has been kept in the waiting also, minus burst time. Turnaround time means the total time which is taken by the process. It includes the waiting time also. So from turnaround time, if burst time is excluded, is subtracted, then we will get the waiting time. And by using the same formula, we can get the turnaround time also. So if we add waiting time plus burst time, then we will get turnaround time. Burst time plus waiting time. So what is response time? Response time, the time at CPU takes process minus time at process arrives, right? Then burst time, I have already told you, this is execution time or running time, the total time slices taken by the process of CPU, that is called burst time. Then completion time is also called exit time, the time at which the process has been terminated. Now come to process scheduling. Process scheduling is the way through which a number of processes, if they are existing in the memory, they are handled, and the method through which a process given CPU time, that procedure, that algorithm is called process scheduling. There might be a number of factors which are considered when a process is considered uh, uh, for CPU time. Uh, it depends on the priority also. It depends on the type of algorithm uh, the system is following. So we will see this concept. What is process scheduling? Process scheduling means activity done by the process scheduler or process manager to decide which process will get CPU time. It is also called low level scheduling, right? And it depends on priority. Priority means that what kind of process is it, means from which program this process has been generated. So quite possible, if the program is very important, is vital, has been generated by the operating system itself, and this is necessary for the system, then it will be prioritized. Similarly, it also depends on that process is CPU bound, means most of the time it requires mostly CPU time, or it is IO bound, means that it has some computation which require mostly IOs, input output devices. So for example, printing a page, so it will require lesser CPU time and more printer time. So that is IO bound. Or for example, a mathematical calculation, in that case, IO devices will not be required and CPU time will be required there. So that is CPU bound. So it also depends on it. Then resource requirement, that what kind of resources are required by the process. Then turnaround time, waiting time, and response time, how much time has the process has been kept in the waiting, or the total time including waiting time and burst time required by the process, or the response time when the CPU took charge of the process to execute it. So it depends on all these three factors, including all these. So it also depends on the kind of process, that if it is interrupted, it is interruptible or not. So if there is some process which cannot be interrupted, quite possible that will be executed at the end. It depends on the kind of algorithm being used uh, by the system. Uh, then scheduling algorithm means, scheduling algorithm may be of different types. We will see. It may be round robin, means in which all the processes are given equal time. It may be first come first serve basis, in which processes are dealt as they come in the queue, and it may be shorter job first, in which it is seen that which process takes lesser time to be completed. So it depends on a number of factors, including the priority and scheduling algorithm. And considering all these factors, it is decided that. Now let's see the concept of process block. It is a data structure to store process information in memory, in RAM. Data structure means, I have told you that the way data is stored in the memory, it is called data structure. For example, array is a data structure. Stack is a data structure. Similarly, queue is a data structure. So this is also a data structure in which the information about the process is kept. So the image is showing a number of different information pieces about any process. So according to your book, it is keeping current process state. Current process state might be that process in ready mode, or it is in running mode, or it is in block mode, or it might be in waiting mode also. So in which mode it is kept in the PCB, process control block. Then process privileges, such as which resources it is allowed to access, this is also kept here. Then obviously the information is executed by using the fetch and execute cycle, and in fetch and execute cycle a number of registers are included. So status of different registers is also stored here in the PCB. So status of program counter, memory address register, memory data register, and accumulator, this information is also kept here about the process. Process priority we have discussed that in which situation the process will be prioritized, and scheduling information, when the process will be scheduled, this is also kept in the PCB. The amount of time the process will need to complete, the total time which is required by the process, that is also kept here. The process ID, every process which is generated by the operating system in memory, that is given a unique ID, and that ID is also associated here and kept in the PCB. After this, we will see process execution diagram. We will try to understand what happens when a process is generated and how it is executed. This diagram I have taken from your book, which process will be given CPU time. Now come to the program is executed, then it generates a process by the operating system that will be in a new program state, and from this state the process will come to waiting state, means it will wait for the operating system. Then it comes to ready state, and from ready state it will come to running state. Running state means CPU has given its time to the process. Then if the process is interrupted, for example, because of any interrupt, then process will go back in ready state or waiting state. And then when the interrupt is handled and the requirement is complete, then again the previous process state will be restored and it will come in running state. And for example, during this process, if it requires some IO, then it will go in block state, where the requirement of the IO will be fulfilled unless the CPU will busy processing the other processes. If the previous process which was requiring any IO has fulfilled its IO requirement, then it will come back to the ready state. And from this ready state, it will again go to running state. And for example, here, if it is complete, then the process will be terminated, right? So this is how the process execution takes place. So in today's class, we have seen a number of different concepts related with Uh, to make the concept more clear, let's see this table from your book, process states and conditions. If the process is going from running state to ready state, it means that a program is executed during its slice. When the time slice is completed, an interrupt occurs and the program is moved to the ready queue. And for example, if the process is going from ready state to running state, it means that a process turned to use the processor. The OS scheduler allocates CPU time to the process so that it can be executed. And then, for example, running state to block state, if the process is going, then it means that the process needs to carry out an IO operation. The OS scheduler places the process into the block queue. Block queue means that it will wait until the IO requirement is complete. Then if the process is going from blocked state to ready state, it means that the process is waiting for an IO resource, and IO operation is ready to be completed by the process. So this is how different states of process, it moves from one state to another state. Now let's see another diagram in which process is being explained, that how it moves from one state to another state. The scheduler has been divided into high-level scheduler and low-level scheduler. High-level scheduler is putting the process in the ready queue, and then the low-level scheduler is responsible to give CPU time according to the algorithm being followed and the priority. So from this ready queue, these are the processes, process 5, 6, and 4. The process is given CPU time, and if the time has been completed, actually this diagram is following round robin. Round robin means fixed time slice is given to every process. So if the time slice is complete and process has not completed its job, then the process either will be put back in the queue. Process can either be placed at the rear of the ready queue or be placed in the block queue if it is waiting for an IO resource. So for example, the process requires any IO resource, for example printer, then it will be put in the block queue, and from this block queue it will go back to the ready queue, and from here it will again wait for its time and its turn, and then CPU time will be given to it using the algorithm and the priority, and then if it is finished, then it will be terminated. So this is how the process is moving from one state to another state using different queues, and this is done by the scheduler, and scheduler is being divided here into two parts: high level scheduler and low level scheduler. Low level scheduler is giving time of the CPU, and high level scheduler is putting the process in the queue so that it could be given CPU time. So here we end our today's lesson. We have discussed a number of different concepts related with processes. We have started from the concept of process. What is a process? And then we have seen that process can have different times: arrival time, waiting time, response time, burst time, completion time, and turnaround time. Then we have seen the process scheduling. This is the activity through which the process is given CPU time, and it is done by the CPU process scheduler or process manager. I also have told you that process scheduling can be divided into two parts: low level scheduling and high level scheduling. By using the low level scheduling, the process manager decides that using priority and scheduling algorithm, which process will be given CPU time. Then we have seen the data structure, PCB, process control block, and we have discussed about the different pieces of information about the process which are kept in the PCB. Then we have seen different states of the process, and we have seen the diagram in which the process is generated, then it comes to ready or waiting queue, then it is given CPU time by the low level scheduler, and then it comes to blocked state if the IO requirement is there, then it comes back to ready state, and then CPU time is given, and then it is terminated. Then we have seen another illustration of different states of the uh, process. So here we will end our lesson, and in next class, inshallah, we will see different numericals related with process and process scheduling. Thank you very much.